going to be congruent, so I can go ahead and put congruent symbols here. And we know that this angle plus 126 has to equal 180 degrees. So I'd once again take 180 and subtract 126, which leaves me with 54. Well, I have 54 degrees to split between these two. So these two aren't 54 degrees, but combined they need to equal 54 degrees. And since they're the exact same measure, we just got to take that 54 and divide it by 2. So each of those would be 27 degrees. We could do the same thing with the 54. I could do 180 minus that 54, which gives me 126, has to be split between these two right here. So that would be, 63, I believe? And all of these are 27 that have 126 in them, and all of them are 63 that have in those. And that should be all of the angles that we need. Another way we could have gotten from 27 to 63 is, what's important about a rectangle? What's the big thing that makes a rectangle? And it has to do with an angle measure. They equal 90 degrees. So we could have also said, because this is 90 degrees, and I knew this was 27, 90 minus 27, oh, that's 63. We could have found it that way as well. I like using isosceles triangles because it's the most forgotten thing in rectangles, is that we have isosceles triangles built into it. That we have to somehow, and maybe I'd put that on my drawing, you know, that little yellow drawing. Maybe put a little arrow that says, remember isosceles triangles. That's why we have that yellow sheet, so we can put little notes to ourselves. All right, so we got that one down. I think it made sense, at least to me it did. Other questions? Yeah. Number two. The dose. Number 2, we have GH equals 14. So GH equals 14. Now the big thing about rectangles and their diagonals is all those little segments are the exact same length. So all of those are 14. Since one of them's 14, they're all 14. I'm also going to note, because that's 11, the one across from it is also 11. What information are we looking for? We're looking for GF. Well, that's 11 because the one across from it's 11. Our GE would be 14 plus 14, which is 28. Our DF is also 28. Our HF is going to be 14. And then finally we have to get DG. Well, DG comes from this right triangle here. So remember, a rectangle has right triangles built into it. So that means that we would have, let's call that x. We'd have a squared plus b squared equals c squared. How do I know which one to put for the c value? Is it always the hypotenuse? Yeah, which is always our long side. It's always the one that's always across from our 90 degrees. That always has to be our c squared. So our x squared is actually a leg. So we'd have x squared plus 11 squared is going to equal 28 squared. Can someone help me out here? I'm going to tell you what I need done. Can someone give me 28 squared minus that 11 squared? Because that's fine to do that in the work. I'll let my calculator do it. 28 squared minus 11 squared. Yeah. 663. And then can someone take the square root of that and round it to the nearest tenth for me, I think? 25.7. And that is definitely not 25.2, right? Do you see what you did?
Yes, I had 663 and I was 633.
Oh, okay. Yeah, it's more likely a calculator or something when you're off by like 0.4 or something. Okay, what else we got? Yeah, Flynn.
Number 14.
14, you got a specific question?
No, I think I get it. I just need to make sure.
So we should have realized that it actually didn't matter. It was a rectangle. It's alternate interior angle. It would have worked for any parallelogram. Any parallelogram has this fact, this alternate interior angle. What do we know about alternate interior angles? They are congruent. So my equation should have been 9x plus 3 equals that 14x minus 27. Now they want DHG, DHG for the angle that they want to find, right? Let's just go through this, I guess, real quick. So I'll add 27 to both sides, gets me 30 equals, subtract 9 from both sides, 5x. So we should have x equals 6. Does that seem right?
Yep.
Well, the unfortunate thing is I need DHG. DHG is this angle here. So this is where it's important that we have a rectangle. Because I can find, see how there's 9x plus 3 here? I can actually take that 6 and go ahead and I can plug that in. So I can take this 6, I can plug it in there. We'll have 6 times 9, which is 54, plus 3 is 59 degrees. So that's 59 degrees. And Flynn, I'm going to let you help me here. If it's a rectangle, what do I know about this measure of this angle?
90 degrees.
It's 90 degrees, so I can get that angle, which gets me that angle, which could help me get to that one.
Yeah, so 90 minus 57.
Yep. So we should have had like 43 degrees,
Yeah.
which would make this one 43 degrees.
Add those together and subtract from my 180.
180, and you have that angle there. So the only hard part is the x shouldn't have been the hard part. It's the understanding how to get to that other angle. Oh, yes, 33, not 43. Thank you. Thank you so much. That could have been embarrassing. 33 degrees. There we go. Thank you. That would definitely change your answer, right? All right, anything else? Okay, we're going to talk about 2 new shapes today. So we already talked about parallelogram. So that's where we're going to start. Parallelogram. First of all, what's the difference between a parallelogram and a quadrilateral? Parallelogram is parallel. It's in the name. Parallelogram, opposite sides are parallel. If you don't have opposite sides being parallel, you just have a quadrilateral. But as soon as you say they're parallel, you have a parallelogram. Now, as soon as we know they're parallel, we also know opposite sides are congruent. I'm going to go ahead and make my marks again. If you don't want to, that's cool. Opposite sides are congruent for a parallelogram. Opposite angles are congruent. So I would do something like this. Dun, 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 dun. We have consecutive angles are supplementary, so I could point to maybe 2 of those angles and say, well, those add to 180. And diagonals bisect each other. Now, for a regular parallelogram, are diagonals congruent?
No. Or, yes.
What if I said the diagonals of a parallelogram are congruent? What kind of shape is that?
Rectangle.
It's a rectangle. So does that mean, are all parallelograms rectangles? No. So do all parallelograms have congruent diagonals? No, they don't. So if you paid attention when I made these marks, for a parallelogram, I made marks that look like this. Like I'd use the 3 ticks, and then I use the 4 ticks, because they're not all the same. If this was a rectangle, we could put 3 ticks on all of them. So a rectangle, 90 degrees, diagonals are congruent. Those are your big things for rectangles. But as soon as you take those away, you have a regular parallelogram. So parallelograms do not have to have congruent diagonals. If you did, you'd say, oh, I have a rectangle, I don't have a parallelogram. I got a more specific thing. So when I give you a general term, you only can give me general answers. So if I ask, does a parallelogram have congruent diagonals? You're going to say, no, it does not. Because if I would have said they are congruent, you say you have a rectangle. So I said the hard part is just keeping all this stuff straight. All right, now we're going to talk about a new shape called a rhombus. Now the plural of rhombus always gets me because it's both rhombi and rhombuses. They both work for it. I don't know, English. So a rhombus. A rhombus is a parallelogram. And because it's a parallelogram, it follows all the same rules as a parallelogram. Except a rhombus is a very specific parallelogram. It is a parallelogram where all 4 sides are congruent. So all 4 sides are congruent. All 4 sides are congruent. So if someone told me to label a rhombus, I'd put tick marks on all 4 of those. Yeah? The diagonals are not congruent. Surprisingly, the diagonals being congruent is solely for rectangles. We're going to talk about rectangles in a second because we're going to talk about a square. But only rectangles have those diagonals that are congruent. In fact, if you kind of picture, like a diamond shape, if you squish it, you'd see that your diagonals can be really skinny and one can be really, really long. So the diagonals are not congruent, but I love the thought there. All right, but we have stuff we can do with the diagonals. The diagonals will be perpendicular, i.e. the diagonals will meet at a 90-degree angle. So our diagonals will be perpendicular. I didn't miss anything. No, I didn't. Perpendicular, which means 90 degrees. So what I'm going to do is I'm going to say my diagonals create this 90-degree angle. And you can put that 90-degree angle anywhere. Because that 90-degree angle must go across from it. It must go there. It must go there. It's just it looks a little sloppy when we put 4 of those on there. So typically we just put 1 and hope that the person reading this understands that all 4 of them are 90 degrees as well. What kind of triangle is this? Right triangle, just in case we need it. Just like with our parallelogram, but our rectangle, how it created those right angles, that created those right triangles. We might have to use our a squared plus b squared equals c squared sometime. All right, it has one more rule. Our diagonals, now this was said earlier and it didn't apply to parallelograms, but for these, your diagonals bisect the angles. Your diagonals bisect the angles. Bisect the angles. So if I was going to put more marks on here, now here's the cool thing about the angles being bisected. What do you notice about all 4 of those angles I just marked up? They're all congruent. That's because it's parallelogram, opposite sides are congruent. And so this diagonal cuts 2 angles that are the same into basically 4 angles that are also the same. So if I told you this is 20 degrees, you're like, cool. That's 20, that's 40, that's 20, that's 20, that's 40, which can get me the rest because we know this is a 90-degree angle because the other ones will also be congruent. We'll put double tick marks on those. Notice how I kind of stagger these. You'll sometimes see them look like one whole thing, but I like to specifically say that this little angle is congruent to that angle there. Where if I told you that this was 20, you'd go, oh, 20, 20, 20, 20. Oh, if this is 90, that's going to leave these as 30, 30, 30, 30. Not 30. Whoa, brain frying. 70, thank you. I don't know why I just, long day. Okay, questions on a rhombus? So your big thing is all sides are congruent, which creates the situation where our diagonals are perpendicular and diagonals bisect each other. Are diagonals congruent? I forgot on a rhombus. No. That's just, if diagonals are congruent, what shape is that again? It's a rectangle. Okay. Got to keep all that stuff straight. Does a rectangle have diagonals that are perpendicular to each other? No, that's just a rhombus. In fact, every time you see these 3 things written out, on the rectangles I put 90 degrees and the diagonals are congruent. Those are specific for those cases. Until we get to a very special shape called a square. A square is a rhombus and a rectangle, all into one super shape called a square. That means every rule that we've learned so far applies to a rectangle. A rectangle has opposite sides that are congruent. Opposite sides are parallel. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. That's from being a parallelogram. Then we can add to it, 4 right angles and diagonals are congruent. That comes from the fact that it is a rectangle. And then we can say all 4 congruent sides diagonals are perpendicular, diagonals bisect each other. We get that from the fact that it's a rhombus. So a square isn't just like a rhombus or a rectangle. It is a rhombus and a rectangle. By definition, it is both of those things. We just give it a special name of square. But it is a rectangle. It is a rhombus, which gives us some cool things that we can write on here. The key ones I always write is, you know what? All four sides are congruent. All of our diagonals are congruent, so it creates a shape that looks like this. Where if I know like one thing, I know a ton of things. I also know the measure, well, this is 90 degrees, right? What's unique about a rhombus and its intersection with diagonals? And it's, what was that? It bisects it. So what happens if I cut 90 degrees in half? You actually know all of these angles are 45 degrees. So if I tell you something's a square, you have a majority of the stuff already down. You have tons of right angles. You also have a right angle right here. So there's lots of places that have right triangles to find missing pieces. But you know all of the angles. If I tell you something's a square, it's 45, 45, 90. It's a 45, 45, 90. Oh, isn't that a special triangle?
Yeah.
So that could be something we could do like our s squared to 2 if we remember it too, rather than using the quadratic formula. Not the quadratic formula, but the Pythagorean theorem. Okay, so those are our two new shapes, a rhombus and a rectangle. Are we good on those? Okay, let's see. All right, our first two questions. Each quadrilateral below is a rhombus. Find the missing measures. Round your answers to the nearest tenth if needed. So I have JK being 12 and JN being 7. Because it's a parallelogram, now listen to my question. Because it's a parallelogram, what other side is 12? Now, just because it's a parallelogram, there's only one side I know is also 12. Yeah. We know ML is. If this was just a regular parallelogram, ML would be. But because it's a rhombus, what else do we know? Michael?
KL and JM are also 12.
Oh, everything is going to be 12. So because it's a parallelogram, opposite one is 12. But because it's a rhombus, all of them are 12. So we can go over here. Are they asking for any of those? They're asking for JL. We don't have that yet. JM. I have that as 12. MN. Nope. MK. Don't have that one yet. All right, diagonal-wise, JN is 7. What does that help me with? What was that? NL is also going to be 7, right? Because these two things are congruent. Oh, are all four of these congruent? Oh, what kind of shape would it be if they're all four were congruent? It would be a rectangle. You are correct. It would be a rectangle, or it could be a square, but a square is a rectangle. So the only way I could put those tick marks like that would be if it's a rectangle. So these would have to be 3 tick marks. So I could say that if we have any of the things that would, JL would be 14. But now they ask for MN. Indeed. Okay, it's a rhombus. I marked all my sides as congruent. What else is something I can mark on here because it's a rhombus? Yeah. Maybe the 90 degrees. Let's go ahead and put a 90 degree symbol here. Oh, and as soon as I put that 90 degrees, I should start realizing that this is a right triangle where I know 2 of the sides. So I have a right triangle. I can go ahead and pull this out. Where I know the hypotenuse is 12. I know one of the side lengths is 7. I have a missing side length. That means we're going to go x squared plus 7 squared equals 12 squared. 12 squared. Take a second and solve this. I don't need the step-by-step stuff. I want it approximated to the 10th place. But do your math and solve for x.
Wait, why wouldn't we, since both sides, 12 and 7, and we're trying to find the missing side. Why wouldn't we just, oh, never mind.
You sure?
I thought that we could just subtract 90, but that's only if it's an angle.
Only if it's an angle, yes. So we do have to use our a squared plus b squared equals c squared. Did anyone solve that yet? 10th. You got it? I don't know. We'll see if anyone else thinks it's 9.7. You think it's 9.7? 9.7? 9.7? We're all good on 9.7. So that means each of these lengths right here are 9.7, which means I should be able to answer the rest of the questions. So they ask for MN. MN would be 9.7. MK would be 9.7 plus 9.7, which would be 18 plus 1.4, which would be 19.4. So just like with your rectangles, you do have to be aware that you do have right triangles that need to be solved. All right, just for the sake of time, let's skip that one for now. Let's go to the square one.
So all of the sides are equal?
Yes. Okay, so I'm going to give you number 3, that we have a square. If I tell you it's a square, you don't have to look at any of the information. You should be able to put stuff down already. Because it's a square, you know all of your angles. You first know all of your big angles are 90 degrees. But that means because it's a rhombus as well, they'll all get split into 45s. So I can just go ahead and put 45 degrees in each of these. And we also know that each of these are 90 degrees on the inside as well. So our BEC is 90 degrees, our DEC is 90 degrees, our AED is 90 degrees, our AEB is 90 degrees. Usually you don't write all of them, but if you want to, you can put those little boxes in all of them. That should take care of our angles. It asks for, what, DAB, a nice dab action. That should be 90 degrees. AEB is 90 degrees. Our CBD, CBD is 45 degrees. Our BAC, back, is also going to be 45 degrees. So as soon as I tell you it's a square, you have all your angles. You shouldn't look for angles in the statement. You should already know all of your angles. It's missing sides that will be the problem. So let's go ahead and go, okay, we know the length of AD. Let's say that's 11. What do we know about all of the sides if one of the sides is 11 and it's a square? They're all 11. 11, 11, 11. Do they ask for any more sides? They say BC is 11, so we should go 11. AC, we don't know that yet. BD, don't know that yet. EC, don't know that yet. Okay. But we have a bunch of right triangles, right? We have a bunch of right triangles. Let's pull one of these bad boys out. We have a right triangle where we have an 11 and we have 2 missing sides. Let's just, for the sake of it, call them, I don't know, S. And let's call this one S square root of 2. What was that? It's a 45, 45, 90. Yep. In fact, can we all look up here really quick? So I'm pulling out this right triangle right here, correct? 40, do we agree that this is 45, 45, 90? You could also pull out this triangle. That triangle is also 45, 45, 90. And maybe this one's easier to pull out because you have the 2 S sides, right? So if this is S s, and this is s square root of 2. What is this length right here? 11 square root of 2. That's where our 45, 45, 90, you still have to know all those rules, that this would be our s square root of 2, which would give us 11 square root of 2. I'm going to go ahead and use the more difficult one, because I think some of us need practice with this stuff. So I'm going to do the more difficult 45, 45, 90 one. We're going to solve for this, which will give me s square root of 2 equals 11. And we'll go s equals 11 square root of 2. Now, here's the good news. We just need to approximate it in these. So let's go ahead and plug this in our calculator and figure out what that length is.
7.8.
7.8. Did anyone else get 7.8? Yep. So each of our little segments are 7.8. So this is 7.8. Maybe I should change my color because we're getting a bit disorganized in here. 7.8, 7.8. So let's see what lengths we're missing. We are missing AC. AC is the entire thing, so that'd be 7.8 plus 7.8, right? What was that?
Wouldn't all the inside, like the lines inside the box be equal?
Mm-hmm. So as long as I know one diagonal is 15.6, they all are 15.6. As long as it's like BD would also be 15.6. And EC looks like it's just part of one, so that would be our 7.8. Questions on that? All right. Do we want to do one of these four? Which one of these four do we want to do in class? Which one of these four do you want me to do? Are there any 4 of them? Is there 6 of them? Oh, I think I rearranged this. Gotcha. Any of those catch your eye that you want me to do? Number 8. All right. If CDEF is a rhombus, find FED. So we're trying to find FED. FED is this angle right here. So this is our mystery angle. What do we know about the diagonals of a rhombus? Because we can see it's a diagonal because it's dealing with these shapes right here. What do we know about the diagonals of a rhombus and how does it work with those angles? They bisect the angle. Thank you. Diagonals bisect the angle. Nothing about 30, 60, 90. They bisect the angle, which means our angles are all going to be congruent. So that means our equation is going to be, that needs to be 5x plus 1 equals 8x minus 20. We need to solve that to find our x value. So I would subtract 5x from both sides, give me 1 equals 3x minus 20. Add 20 to both sides, we have 21 equals 3x. Divide both sides by 3, and we should come up with x equals 7. But how do we get to angle E with that information? Plug it into one of those? 8x minus 20. Let's go ahead and do that. So we're going to plug that into that 8x minus 20. So that will give me, 8 times 7 minus 20. What is that?
36.
Okay, so now we know that this angle right here is 36. And I'm going to bring up a shape right now. We have a triangle right here. What kind of triangle is the one I just highlighted? A right triangle. Not 45, that's only if it's a square. since it's a rhombus, our diagonals intersect each other. So this is a 90 degree. We have a right triangle. So we're going to take 180, subtract 90, subtract 36 from it. 54 degrees will get me that measure right there. Is that our answer? What was that? It's not 54 times 2. Oh, it could be, yeah. I agree with that. Because it's a rhombus, right? Because it's a rhombus, both of these have to be congruent to each other. So that would also be 54 degrees. So our end answer is going to be 108 degrees. All right, let's look at number 10 real quick. If FGYHI is a square, solve for x. Why I want to point this out is because there's just one equation. I can't set it equal to another equation. Yeah. All angles are 45 degrees. That means you have to know when I say square. That's why maybe on that yellow drawing you have with all your stuff, you might want to put those 45-degree angles in there and start memorizing the fact that all of those little angles are 45. And we just go 7x plus 3 equals 45. 7x equals 42. I believe I approximated. No. I don't know what I'm thinking. We would have y equals just, or x equals 6, and we'd be done, because I didn't ask for any of the other stuff. All right, you see all the problems we missed? You need to do that with your group. So today, this is a group effort. I'm also going to bring up on your homework really quick, look at number 3-ish, kind of in between 2 and 3. I don't think I have a number on it.